we set ourselves the goal of making Xen the best hypervisor for OpenStack. To better understand what that means, I'm going to go a little bit into a few details of how OpenStack works. So I don't know how familiar you are with it, but OpenStack is made up of many, many different components. Most of them are actually optional, so you can have very different OpenStack configuration, and two are usually not the same, right? And for every component, many times there are optional alternatives. So you can have different object storage components and different UIs and so on. But if there is one component which is core and almost all OpenStack deployment have, that is certainly Nova, that is the compute engine. So Nova is the bit of software in OpenStack that sits on top of your hypervisor and calls into the hypervisor API to create virtual machine, destroy virtual machine, and handle everything related to virtual machine. As you might expect, Nova has many drivers, one for each of the hypervisor Nova supports. So there is Nova with VMware drivers, Xen drivers, Hyper-V drivers, KVM drivers, and so on. Well, in practice, it's actually not that simple. It's counterintuitively, the Xen driver is actually the Xen API driver. So the Xen API is an interface exported by Xen Server. Xen Server is the Citrix virtualization product. Actually, the component that implements this API is fully open source. Its name is SAPI, and you could actually install it on your favorite Linux distro and have a Xen API capable host. There is also, I think, an open source version of Xen Server, so check out xenserver.org. But the matter of fact is here, when you install Xen on your Ubuntu or on your CentOS, this is not what you're going to get. The other thing that is different from what you might expect is the KVM driver. Because actually, the KVM driver in Nova is not really the KVM driver either. The KVM driver in Nova is the libvirt KVM driver. So Nova can't actually communicate with KVM directly, and everything goes through libvirt. So this might be a bit more accurate. So Nova can communicate with KVM via libvirt, but can also communicate with other hypervisors via libvirt, among which Xen. So you can run on top of Xen in two ways with Nova, either with the Xen APIs or via libvirt. So actually, Xen API support in Nova is already pretty good, and Lars mentioned earlier the various groups. I'm gonna go into more details. So you have Group A, Group B, and Group C. So Group C of support, it means the driver is present in Nova. Maybe there are some tests, but we don't really know if they run at all. Group B of support means we have the driver in Nova, and there is a CI loop running. An external party is running a CI loop on this driver, and is feeding back to OpenStack.org the results. Most actually drivers fall into this category. And then you have Group A, where only KVM is, and Group A means actually the OpenStack CI loop run by the IT guys at OpenStack.org. That is based on basically only KVM, and that's why KVM is in Group A. So Xen API, the Xen API driver was already in Group B. So there was already a CI loop running. It was already well tested. It didn't break easily, and so on. So when I initially said our goal is to make Xen and Nova, Xen the best hypervisor for Nova and OpenStack in general, I mean Xen via libvirt. Why? Well, because this is most likely the first experience you're going to have with OpenStack. So if you're a Xen user and you want to try OpenStack, you're most likely to try that way, because that's the simplest way to do it. You just install Xen, install libvirt. It's already packaged up in your distro. and then you only need to get OpenStack the same way you always get OpenStack following the OpenStack docs, and it works. Also, this is the way, as a developer, it's the easiest way as a developer to set it up, because you only need one machine. You just need your Debian distro with Zen, Libvirt, and Nova, and that's it. And you can do all your development there, as most people do with KVM already. While with Zen Server, for example, you will have a separate host. So I think it's quite important from a community perspective that we get Xen via Libvirt working correctly for both the developer community as well as the user community. So just for your reference, actually, Libvirt can communicate with Zen with 2 different ways, because life is never easy, right? Actually, I mean, honestly, you should never see this, but I'm just telling you as a reference. So Libvirt used to communicate with Zen via a toolstack called Xend, a Python toolstack we had until a couple of years ago. Now has been deprecated for a while and is not even present. We remove it from the code base. So yeah, Xend is gone. So when I'm saying Xen via Libvirt, I actually mean Xen via libs and light via Libvirt. But really, I mean, you should never see Xend. I'm just telling you this because in case you have a very old distro, like maybe a CentOS 4 or something, and you see Xend around, then you know it's really time to upgrade. Right. So, as I said, so the goal is to get Xen via Libvirt in Group A within 1 year. And to get Xen via Libvirt into a state which people actually want to use it for development or for tryouts, for testing. But where were we when we started this project? I said at the beginning of the year, so in January. So it was terrible. So we were in Group C. That means, yes, it was a driver, but did it work? We tried it, and it didn't. Because obviously, because it's not tested, there are transient bugs. So people, improve Nova, and then they change something, and maybe something leaks from the KVM Libvirt driver into the Xen Libvirt driver, something gets changed, and it doesn't work anymore. So yeah, not only didn't work manually, but obviously if you tried it and it didn't work for automatic test as well. So Tempest is a testing suite that is used within OpenStack to validate basically any changes to Nova. So it's actually quite complex. It runs thousands and thousands of tests. So obviously Tempest couldn't complete. So what did we do? We started fixing all the bugs. Mostly were actually quite simple, and because the vast majority of the driver is actually common in Nova. It's just the Libvirt driver. It's not really hypervisor specific. There are a few bits that are hypervisor specific there, because Libvirt is not really that good as an abstraction level. It's more like an hypervisor communication library rather than an hypervisor abstraction layer. But that means that most of the code in Nova was actually already very well tested, just with KVM and not with Zen. So the bugs were typically trivial, like small configuration issues that only work with KVM that creeped out into the generic Libvirt bits. So once we fixed those bugs and we fixed some of the Libvirt bugs we had, then we could finally install the Xen and Libvirt driver, Xen Libvirt and OpenStack, and it will start working. After that, what did we do? After that, we started deploying our own CI loop to validate this driver. But the bottom line is, just within 6 months, we managed to get the driver in Group B. And this is also, most of the part is thanks to the team Lars mentioned earlier, and Bob Ball, that is not here, unfortunately, but really contributed a lot of this, because he was the one that set up the CI loop for Xen Server earlier, and helped us out setting up the CI loop for Xen project. And then now is running on a Rackspace account, as I was saying. So this is a bit of a strange concept, but in OpenStack they use nested virtualization to do testing. So it's kind of almost a requirement. So this is why basically you are using Rackspace. So we are allocating VMs on Rackspace, installing Ubuntu, installing Xen there on top of a VM, right? And then installing OpenStack, and inside this VM, starting more VMs. And this is how we do testing. And as you can imagine, it's pretty slow. It's in fact so slow that we had some stability issues, and they were due to timeouts. What I mean is, Lips and Light has a timeout for starting secondary processes, such as QEMU. And whenever Lips and Light start QEMU, it checks the time and see how long it takes actually for QEMU to come up. And the maximum time it thinks in QEMU might possibly need is 10 seconds. Why? Well, because QEMU basically just starts and says, OK, I started. So it usually takes about a second, less than a second. But in this environment, it was so slow that we will hit once in a while this timeout, causing random failures. So we would just see that suddenly one test will fail in OpenStack. And it wouldn't be always the same. It would be randomly. One test every 1,000 will fail. So it took us quite a while to narrow this down and then figure out it was just a genuine timeout issue. We thought it would be a QEMU issue, a libvirt issue, or something else. No, it was just a timeout. So now we increase it to, I think, 60 seconds, and it's working. So the CI loop is up and running and stable for a while now. Stability for the CI loop is really important, because if you start giving false positive or false negative, it's not reliable anymore, and therefore, obviously, the CI loop is worse than if we didn't have one. So that was basically the next step after getting Xen via libvirt working well, was getting the CI loop on Rackspace working well enough to be trusted. And once it was trusted, we waited for a week or two. We saw that actually all the results were correct. And then we went to the Rackspace people, and we went to the OpenStack people, and we said, well, we have a third-party CI loop here run by Xen project, and we want to hook it up. So are you OK with that? And they said yes, and that meant we are now in Group B. And to explain a bit more in practice what it means, I'm going to show you a couple of web pages. If you look here, this is jenkins.openstack.xenproject.org. This is a web page of our own CI loop. And it's running a few tests as we speak. As you can see, most of them are actually green. Green means that they passed. This is an interesting curiosity. So the way the tests are triggered on OpenStack is actually quite different than Xen project. This is something we mentioned earlier. So in Xen project, usually somebody sent a patch. There is some reviews. The patch gets resent. Eventually, one of the maintainers accepts it. The patch gets committed to what we call the staging tree. The staging tree then gets automatically tested in the Xen project column. And once the test passes, the changes are pushed automatically to the master tree. That is what people usually use. In OpenStack, it doesn't work like that at all. So you write your own changes, then you commit them, and then you push them out using git review. That is a Gerrit command. So the changes then get into review.openstack.org. That is all managed, it's all web-based. So the reviews are done there. And then once the patch is accepted, so get enough +1, basically, the commit get accepted in the main code base. This is going to be interesting because it actually matters. And voting rights, it really means that now we can be part of that voting. So in fact, so this is just to show you a bit of trend. And this is basically the number of tests run by the CI loop. They are mostly green. It means they're passing. This is actually how it should be. So the red ones are the one basically didn't pass, but obviously somebody somewhere once in a while sends out a broken patch, so it's normal that there are some red tests in there. Right, this is review.openstack.org, what I was saying. Here you see a lot of commits. Not all of them have been accepted yet, and they are for different projects. So there is Nova, Rally, Heat, Cinder, Neutron, and so on. Now, I basically picked this morning, an hour ago, a commit at random for Nova. And what we see here on the left yeah, is the people that did code reviews. Here at the bottom, we see a +1 from Jenkins, a +1 from the VMware CI loop, a -1 from what is most likely a person, a +1 from a +1 from a dataset CI loop, and a +1 from the XM project CI loop. So we are here, right? So being in group B means having voting rights. So that means being able to say +1, this commit passes our test, is okay for us. So the CI loop, in a way, they vote as if they were maintainers. So there needs to be 2 humans there to give a +1 in order for a commit to get into the code base. But obviously the humans go and see the result from the CI loops, and if a CI loop give a -1, they're really unlikely to accept the code unless they deliberately want to break an hypervisor, and it doesn't happen often. It happened a couple of times, but only a couple of times in 2 years. So this is a really important step, as you can see. So we not only go from having a regular CI loop running and validating changes, but we are also show the maintainers that the code is actually working. We tell the maintainer that when a commit is broken, before the commit reaches the main code base in OpenStack. And somewhere, so Jenkins will be, just for reference, I think here is the main gate, the one that is running KVM. And one day we could have a Jenkins end there that basically is run by the OpenStack CI loop infrastructure team, based on the XM project hypervisor. So yeah, I think we did really good. And now we are aiming at group A. So this is what I just showed you. So how do you set up OpenStack with Reliably bird? So this is basically what we do in the CI loop, and it works pretty well. So you install the latest Ubuntu LTS, you install the Xen packages from the Ubuntu repositories as usual. Then you clone DevStack. DevStack is the main way to deploy OpenStack from source. It's what all developers use, and it's also what the CI loop use. It's basically a set of bash scripts with a config file, and DevStack takes care of cloning all the relevant trees, building them, installing them, and pre-configuring them for you. So it's really simple to use, and usually you just clone DevStack and you run stack.sh. It takes a really long time. When one is finished, you don't need to do anything else. So with Xen Vert, there is only one difference. Just need, before running stack.sh, you need to change one line in the config file and say libvirt type equals Xen. And that's all. So we are one config line different from the default that is KVM. So I think this is a major achievement, because it's not just that it's working, but it's actually extremely easy to use, and it's extremely similar to the default hypervisor. It's very, very easy to switch from one to the other. So these are some tuning options. So anything that is familiar to Xen already knows them very well. But in case there are some users here that want to try this out and want to improve performance, so I'm giving them out as a reference. So we have also a wiki page on performance tuning that you can check out at wiki.xenproject.org that is pretty full of information. So I think a good start would be to limit the amount of DOM0 memory. So DOM0, keep in mind that in a Xen deployment, DOM0 is basically a service domain. So if you give too much memory to DOM0, it's basically less memory that you give to the actual VM you want to run. It also helps with scalability. So especially if you bought a recent Intel server that has a large amount of memory, you probably most definitely want to reduce the DOM0 mem. And you do that by editing the bootloader config file, so your grab.conf, and you change, you add one parameter to the Xen command line, and the parameter is DOM0_mem equal the amount of memory you want to assign to DOM0. And 1 to 4 gigabyte is usually a good starting point. Obviously, if you're running on an 8 gigabyte old machine, you probably don't want to pass this option. I mean, the default is going to be OK. Even more importantly, you might want to reduce the number of vCPUs. So by default, the number of vCPUs created for DOM 0 is equal to the number of physical CPUs. That means if you're running on a 64 cores x86 server, you're going to get 64 vCPU in DOM 0. This is actually hurt performance because every time you want to do an operation that requires synchronization across DOM 0 vCPUs, now you have to synchronize across 64. And actually, you don't need that many in a service domain. So yeah, so we'll definitely recommend to pass DOM 0 underscore max underscore vCPUs equal something like 4. You can try out and run some benchmarks and see what works best for you. Another one that is similar is DOM 0 underscore vCPUs underscore pin, this one. And it tells the DOM 0, the Zen scheduler to not move around the DOM 0 vCPUs. And this also improves performance. So the best block backend for Xen has always been, for a long time, LVM, because we have an in-kernel block backend in Linux and also in FreeBSD that can work with LVM volumes or physical partitions, and that is much faster than having user space block backends. So if you don't need copy and write, if you don't need QCOW or stuff like that, I would definitely recommend to use LVM for your VM disk storage. And to set this up in OpenStack, you just need to edit the Cinder configuration file that is under etc cinder.conf. You just pass the volume name, the LVM volume name, that is volume underscore group equal your LVM volume group name. And finally, the last option is PV or HVM. So on x86, we have two types of guests, PV guest and HVM guest. PV guest has the old style of guests, like Linux, FreeBSD. They need to be, actually FreeBSD, I'm not sure it runs as PV guest. NetBSD does. But basically, the operating system needs to be explicitly ported to Xen in order to run in this mode. The other type of guest is HVM, initially introduced for Windows, because operating system can run unmodified as HVM guest. But then HVM support was introduced, improved HVM support was introduced in Linux as well, and other operating systems. So to switch between the two, you need to edit the Nova metadata. And you do that by using Nova image meta set VM mode equal HVM if you want to switch to HVM guest mode, or Nova image meta delete VM mode if you want to switch back to the default that is PV. As a reference,
you have both at the same time or only?
No. So as a reference, usually from the performance point of view, HVM guests are faster on modern hardware. So if you have an Intel box or an AMD box that is 2 years old or newer, you probably want HVM guest. If you have an older box, PV probably give you a better performance. But it also depends on the workload. So again, you might want to run your own benchmarks to see. Depending on the workload, you might get different results. Right, so I'm almost at the end. So I wanted to give you a few points to get into contact with us. So the mailing list, as usual, it's NDVL. We have two wiki pages, and you might be interested on the wiki. One is OpenStack that tells you everything we know about it, how to set it up, like what I just told you, and more information. How to set up the CI loop, even if you want to set up your own. And the tuning Xen for performance contain all the tuning option I gave you and more. Yeah, but please join the OpenStack working group. We need people to help us out, especially in the maintenance of the CI loop itself. So we meet once a month. Actually, I think it's once every 3 weeks. So it's very low impact on your work schedule. We have a mailing list that is WG minus OpenStack. So please engage with us if you are interested at all and want to make sure the Xen project works well with OpenStack. That's it. So do you have any questions?
Hi, this is Manish Cheggi from Cavium. So, what would it take to add OpenStack support for Zen running on ARM?
So I think for ARM64 and ARM, actually, we have all the pieces we need already. So we don't have a CI loop running on ARM yet, but theoretically it should work. So the work to enable OpenStack and Zen and Reliably on ARM was done back in December, and we have good data points to prove that it was working correctly, and even Tempest could run, but we haven't set it up on ARM64 yet. But it's possible. Yeah.
I tried it on the Cavium ThunderX platform way back in March. So the support was broken actually.
But keep in mind that you need to use always the latest tree. So one thing is, if you use Nova from Ubuntu, for example, or even more interesting, if you use libvirt from Ubuntu, usually they lag behind. Even worse, if you use libvirt from CentOS, it picks like 1 or 2 years old libvirt versions. While if you did the work back in December, the patches is going to go in only in the release that is 3 months later, so it's not going to be in Ubuntu. So basically you need to pull the latest trees. Okay. But if there are a few minor fixes, we will find them, and if there are a few minor bugs, we will find them and fix them.
So is there any effort on that? Yeah,
so we are actually working, so my team, Anthony Perard and I are working on getting OpenStack running on Xen, and on ARM64 as we speak.
So maybe we can talk after this.
Yeah. Any other questions? You don't need to stand up if you don't want to. I will repeat the question. No, okay, and then next speaker.